Hi, in this video I'm going to be telling you some basics about the Rubik's Cube that will help you to solve it. So the first observation I want to make is that there are 27 little blocks. One of them is invisible in the center of the cube that make up the whole Rubik's Cube. These little pieces are sometimes referred to as cubies. I'll probably just call them pieces. And there are three different types of pieces that make up the visible blocks of the Rubik's Cube. There are pieces with just one color on them. We'll call these central pieces because they're in the middle of each of the sides. There are pieces with two colors on them. We'll call these edge pieces because they're in between two of the faces or sides of the cube. So central, edge, and then corner pieces. And the corner pieces have three colors on them. So one color, two colors, three colors. And let's start by talking about these central pieces. The central pieces determine which color each face is going to be in the solved orientation of the cube. And here's the reason. If you turn one of the faces of the cube, let's say the green face, if you turn this face of the cube, the edge pieces and the corner pieces change position, but the central piece does not. So basically, no matter what you do to the cube, those central pieces are always going to stay in the same positions relative to each other. So the green face is always going to be opposite the blue face, at least if you have a standard colored cube. In a standard colored cube, the red face is opposite the orange face because those central pieces are opposite each other. And then the white and yellow faces are opposite each other as well. That's the very first observation. The second observation that I want to make is that the pieces, the rest of the pieces can be oriented in different ways. So what could happen is you could have a yellow and blue piece that's flipped around in this way. So this edge piece could have its so-called orientation. It could be in the right spot, but in the wrong orientation with yellow on this side and blue on this side. An interesting fact about the cube is that not every possible orientation can happen. So it's not possible to just have one edge that's wrongly oriented. There will always be an even number of edges that's wrongly oriented. The corners can also be oriented differently. So for example, this blue side could be on this face, the red side could be on this face, and the yellow side could be on this face. And again, there are some limitations about how the pieces can be oriented. So usually as well, different types of orientations typically occur in pairs with respect to the corner. You can't just have one corner that's not oriented correctly. And because of this, if you pop the Rubik's Cube apart, if you actually undo these pieces and break it all up, which I'm not going to do right now, but if you do that and put it back together again, if you just do this in a random way, it's possible that the Rubik's Cube will not be able to be solved from the random position that you put the pieces back in. In fact, 1/12 of all the random orientations of the cube are possible. So the probability that if you just take this apart randomly and stick it back together, putting the pieces wherever you want, the chance that it will be solvable is 1 in 12. The other thing I wanted to talk about in this video is the typical notation that you'll see online about the moves that you can perform on the cube. So these moves typically presuppose a choice of side for the duration of an algorithm. So what do I mean by this? So you want to say, let's say the blue face is going to be the front face of the cube, and the red face is the up slice or the top of the cube. So then the orange face would automatically be the bottom. And with these choices, the yellow and white are also fixed. In this case, yellow is on the left and white is on the right. Okay, there's also the face that's opposite the front slice, and that's called the back slice, and in this case it would be green. So the notation that you'll see online for different moves refers to the first letters of each of those slices that I've named. So the front slice is usually denoted by F, And if you turn it in the clockwise direction, that is usually the move that's denoted by F. So clockwise, of course, it means you have to be thinking of looking at it and from a certain direction. So looking head on at this front slice and making a clockwise turn, that will be denoted by the letter F. And the same works for all the other sides. So on the right hand side, if you're looking at that side and you do a clockwise turn, that is the move R. Now I want you to notice something. Let's say we do R. What would L be? The left side, you have to be looking at that face and doing a clockwise turn. It's kind of the opposite to what the right move is. So R, clockwise, lifts the orange side up, and L brings the red side down, because you have to think about it from that side making a clockwise turn. This is just a convention, so it's a choice that's made. Fortunately, there is a standard way of writing this notation, so you can look on any website and chances are that they'll use this notation for describing the moves that they are talking about. Then the other two things that I will, we've still got to mention the up slice. So again, looking at this side, making a clockwise turn. And then the down slice, looking at that side, making a clockwise turn. And once again, up, which is denoted by U, and D, which is denoted by D, down, which is denoted by D, are opposite each other when viewed from the front. So down is going to move this yellow slice to the left, and up is going to move the white side to the right. And finally, there's back. So if front goes this way, back is going to go the opposite way, right? Because again, you have to think about looking at that side, making a clockwise turn. Now, fortunately, there's also notation for multiple moves that you can make on the cube. So if you can do a double turn, and that would be denoted by F2. So, and that's the same for all the sides. If you do a double turn, it's just denoted by a 2 after the letter. And notice that if you do this backwards, you also get the same result. So front to clockwise and front to counterclockwise are exactly the same move. If you do front, let's say clockwise 3 times, well, obviously that's the same as doing one counterclockwise turn. And it's useful to have notation for counterclockwise terms. We use an apostrophe or a prime to indicate this. So if you see F prime or F apostrophe, that means move the cube in a counterclockwise direction, again, when viewed from the front of that face. So that front prime would be in this counterclockwise direction. Right prime would be, again, counterclockwise. Whoops, counterclockwise. So it would be forwards in this case, which would be the same direction as left. But left inverse, that's how we say that move. Left inverse is denoted by left apostrophe. That's the counterclockwise move when viewed from that side. Okay, that's it for this video.